Welcome back to the Aquatic News Network, where the science is icy and the takes are spicy. Today's quest, a glacial power-up turning Arctic waters into a bloom bonanza. Well, let's jump right into this.
That's right, Jesse. Greenland's Jakobshavn Glacier, aka Cermak Kujalek, is shedding over 300,000 gallons of meltwater per second during peak summer. That's enough to fill a retro arcade every blink of an eye.
Wait, hold up. I thought glacier melt was just, I'm sorry, 300,000 gallons of water. Are you freaking kidding me? I thought glacier and melt was just bad news. Ice loss, sea level rise, doom scrolls. You're telling me it's also feeding the ocean?
Exactly. That fresh meltwater is like a buoyant elevator. It rises through the salty depths, dragging up nutrients like iron and nitrate from the seafloor. It's a nutrient respawn zone, and phytoplankton are the first to cash in.
So these tiny plant things, phytoplankton, are basically the XP farmers of the ocean?
Bingo! They're the base unit of the marine food web. Krill eat them, fish eat krill, whale eat fish. Without plankton, the whole food pyramid collapses like a poorly stacked Jenga tower. I don't even think it's called the food pyramid anymore, actually. Now it's starting to all make sense.
And so this bloom isn't just a little uptick. NASA-backed simulations show summer growth surging by 15 to 40% near the glacier. That's like unlocking a cheat code for the Arctic productivity.
Scientists use the Echo Darwin model, a supercomputer-powered simulation that crunches decades of ocean data. It's like SimOcean meets Oregon Trail, but with real physics, chemistry, and biology colliding in one fjord.
Okay. Confession time. I used to think plankton was just pond filler. But this is like discovering the NPCs have been running the whole ecosystem behind the scenes.
And that's your arc, Jesse. From casual gamer to plankton evangelist. Because when you realize the microscopic marvels are absorbing carbon, fueling fisheries, and reacting to glacial dynamics like a real-time strategy game, you start to see the ocean as a living system.
Not just living, leveling up. And the fact that this bloom happens after spring nutrients are spent, that's clutch. It's like mid-season patch update for the Arctic food web. This is crazy.
Exactly, and it's happening in one of the most remote iceberg-infested zones of the Earth. Scientists couldn't just roll up with a net, they needed supercomputers to simulate the whole thing.
So, what would be the takeaway for our viewers, Tommy? Whether you're a joystick jockey or a lab bench lifer, this story proves that nature's mechanics are as elegant as any gaming engine.
And that collaboration between coders, oceanographers, and data nerds is what makes this segment a win. It's not just science, it's co-op mode for understanding the planet.
Final boss thought. Greenland's ice may be melting, but it's also revealing hidden systems that feed the world. And if you're not paying attention to the plankton, you're missing the real endgame.
Stay curious, stay pixelated, and remember, every glacier has a story and every drop of meltwater might just be a nutrient delivery system in disguise. Before the sun warms the petals, before the bees stir, before the wind remembers its name, the hummingbird is already airborne. A creature so small it could vanish in a blink, yet so mighty it rewrites the laws of flight, metabolism, and memory. This is not a bird. This is a biomechanical fever dream. Each wing beat is a whisper against gravity. Up to 80 times per second, the hummingbird's wings slice through the air in figure eights, generating lift on both the upstroke and the downstroke. No other bird does this. Not hawks, not owls, not eagles, only hummingbirds. Their hearts beat over 1,200 times per minute. Their breathing rate exceeds 250 breaths per minute. Their flight muscles make up 30% of their body weight, more than any other bird. They are built for speed, for precision, for defiance. To fuel this frenzy, hummingbirds consume half their body weight in sugar daily. Their tongues are not simple scoops, they are split capillary tubes, flicking in and out up to 20 times per second. They don't lap, they siphon. Each flick draws nectar upward through capillary action. The tongue compresses, then springs open inside the flower like a straw with a heartbeat. Some hummingbirds migrate thousands of miles. The ruby-throated hummingbird crosses the Gulf of Mexico in a single non-stop flight, 500 miles over open water. No food, no rest. The rufous hummingbird travels up to 3,900 miles one way from Alaska to Mexico. They do this on a belly full of nectar and a prayer. Their bodies convert sugar to energy with ruthless efficiency. They burn hot, fast, and clean. Hummingbirds remember every flower they've visited and how long it takes each to refill. Their brains are proportionally larger than any other birds. They are nectar's accountants with wings. They defend feeding zones with aerial jousts, high-speed dives, chirps, and tail flares. They are not passive pollinators. They are sugar-fueled sentinels. Hummingbirds pollinate hundreds of plant species. Some flowers have adapted specifically for their visits. Long tubular shapes, bright colors, high sugar content. Without hummingbirds, these plants would fade into myth. They are not decoration. They're not infrastructure. They stitch ecosystems together with every sip. You don't need a rainforest to help hummingbirds. A single feeder, a patch of native flowers, a pesticide-free garden. These are lifelines. During migration, even a suburban bloom can be a critical refueling station. In a world of shrinking habitats, every flower counts, every sip matters. They are the pulse of pollination, the heartbeat of migration, the glittering proof that small can be mighty and beauty can be functional. They are hummingbirds, jet-fueled jewels of the Americas.